Hey, gonna do another example of a Lensmakers equation slash magnification equation type question, just to kind of show how all the details are important in these questions. So I've taken this one from an old diploma exam. It's got a multiple choice answers that we can choose from when we're done. And with any luck, when we are finished, we have one of these answers and it's the correct one. So let's take a look at the question. At what distance above a page would a converging lens that has a focal point of 10 centimeters have to be held for the image of the letters to appear upright and 3 times as tall? Well, let's do our usual thing, which is try and pull some of the information out just to kind of see what we're given in this question. I mean, I see right away they say the focal point is 10 centimeters. Now, I really, if there's anything that's critically important that easy to overlook is we can't just blindly say focal point is 10 centimeters. We need to question whether it's a positive or a negative 10 centimeters. So going back to this question, the key word here is that we're dealing with a converging lens. Converging lenses look a little something like this. Principal axis, converging lens looks like this. And what happens with a converging lens is parallel beams of light that come in converge on a common focal point. So as these rays of light come in, they all converge on a focal point, and that makes this a real focal point. So understanding the terminology, having a sense of how rays interact with lenses and mirrors, really important that becomes second nature at some point. But I'm pretty confident saying the focal point is positive 10. Now, they tell us also this. We're going to hold the lens in such a way that the image of the letters are upright. Now, that means the height of my image, I don't know it, but it's going to be positive. We'll see if that's important. And the magnification is what they're telling us here. It's 3 times as tall. Not only is it 3 times as tall, it's positive 3 times as tall. So our magnification is positive 3. So I think I've harvested all the information I can from this question, all the quantitative information that I can from the description of the scenario. So now we want to proceed. Now, at first glance, we don't have enough information to find DO right away with, is we want this, how high do we have to hold the lens from the page? So we're really looking for what is the distance between the lens and the object, the piece of paper. That's what we're after. And both the magnification equation, which says m is equal to minus di over do, or the Lensmakers equation, both of these equations have do in it. So both of them may be possible ways to solve for the distance of the object, but not with the limited information we have here. So one of the things I hope people are starting to recognize is if you don't have enough information, it may be that you have to use some sort of systems of equations to solve for this. So let's see what happens when we put our information into the magnification equation. If the magnification is really positive 3, and that equals negative di over do, then what I can do is I can make an equation for di. I can say that di is equal to negative 3 times do. So I have an equation here with 2 unknowns, but I can make an equality for di. So now I can put di in terms of do. And you might say, well, who cares about that? Well, I care about that because now if I put information into the Lensmakers equation, 1 over 10 centimeters is equal to 1 over di. Except instead of saying di, I'm going to put negative 3 do because that is, in terms of do, that is what di is. Plus 1 over, I'm just going to leave this do. So you can see what's happened here. Instead of having only one of my variables known and 2 unknown, I now have an equation that has just 1 unknown variable. It's the do. Now, how you proceed from here is a little bit up to interpretation, but I would do this myself. I would say 1/10, 1 over 10, is equal to 1 over negative 3 do plus 3 over 3 do. So I've essentially come up with a common denominator by multiplying the top and the bottom of this by 3. So this is 1/10. This is, I can take the negative here and put it in front if you like. So negative 1 over 3 do over 3 do. Well, 3 over 3 do minus 1 over 3 do is equal to 2 over 3 do, right? 3 minus 1 is 2, and I have a common denominator here. So now I have this. 1/10 is equal to 2 over 3 do. Let me just write that up here just to clean it up, and then I'll do some math to isolate my do, but this is what I've ended up with. So I'm going to cross multiply here. 1 times 3 do gives me 3 do. 2 times 10 gives me 20. So now I've gotten rid of the fractions, and I just have these everything in the numerator. Divide both sides by 3, and now I have do is equal to 20 divided by 3. Yeah, 20 divided by 3, and 20 divided by 3 is not quite 7. It's probably 6 2/3, but let's find out on our calculator. Here we go. 20 divided by 3, yes, 6.67, if I'm allowed to have 3 significant digits. And I believe I am. 6.67 centimeters is do. So definitely have an answer on here that I like. That's B, 6.67. I'm going to point something out here in terms of significant digits. I don't want to get into it too much, but people are going to say, well, wait a second, don't you only have one significant digit because of this 3 that you used in your calculations here, and it's all throughout? And I would say no. In this case, we are trying to design something as best we can to come up with 3 times the magnification. So that number in my mind is kind of the perfect number we're looking for. So I don't think it affects my significant digits. It's a multiple choice anyway, but if you were writing an answer for me, I would expect 3 significant digits here. The distance to the object should be 6.67 centimeters. End of story. So, moral of this question is this. Number 1, when you're doing Lensmakers Equation, Magnification Equation, please pay attention to the words, the description, and if necessary, draw yourself a little diagram. Here's my page. Here's my converging lens that I'm going to hold above the page so that my eyeball up here sees something that is 3 times as big as it was before. So here's a letter on the page. Doesn't matter what size it starts. Get a sense of what's going on here in order to have all the information. I didn't have to have the diagram necessarily, but I certainly had to read the words as much as I paid attention to the numbers. Then, if it doesn't look like you have enough numbers, persist. Like, get yourself a system of equations or something of this so that you can get enough information to solve. So this one's like definitely not level 1 Lensmakers Equation, Magnification Equation, probably like, level 2 or 3 in terms of difficulty, but it's doable. And for a student studying physics, this math should not be the thing that gets in the way.